ARM has released its first in-house chip, marking a shift from its traditional role as a company that designs chip architectures to one that also builds complete silicon products. For years, ARM has operated differently from companies like Intel or AMD. Instead of manufacturing its own processors, it created designs and licensed them to other companies such as Apple, Qualcomm, Samsung, and MediaTek. These companies would then customize ARM's designs and build their own chips. This model made ARM one of the most widely used technology providers in the world, especially in smartphones. With this move, ARM is stepping closer to becoming a direct participant in the chip market. The new in-house chip is not meant to replace its licensing business. Instead, it serves as a reference design that demonstrates how ARM's latest architecture can be fully implemented into a working, optimized product. In simple terms, ARM is showing what its technology can achieve when everything, from architecture to final chip, is tightly integrated. This approach has a few important implications. First, it allows ARM to control performance and efficiency at a deeper level. When companies license designs, they often modify them, which can lead to variations in performance. By building its own chip, ARM can present a version that reflects its intended design goals without compromise. Second, it strengthens ARM's position in new markets such as data centers and artificial intelligence. These areas demand high efficiency, scalability, and performance. By offering a complete chip solution, ARM can better compete with established players and prove that its designs are capable of handling demanding workloads. Another reason behind this move is the growing importance of custom silicon. Large technology companies are increasingly designing their own chips to gain better control over performance, power consumption, and cost. By creating its own chip, ARM can stay relevant in this shift and provide a clear roadmap for partners who want to build specialized processors. This does not mean ARM is abandoning its partners. In fact, its ecosystem remains one of its biggest strengths. Companies will continue to license ARM designs, but now they also have a more concrete example of what is possible. It can act as a baseline or starting point for further customization. There are also strategic considerations. The semiconductor industry is becoming more competitive, especially with the rise of artificial intelligence and high-performance computing. By developing its own chip, ARM gains more influence over how its technology is used and positioned in the market. However, this move comes with challenges. Some of ARM's existing partners could see this as potential competition. If ARM begins offering complete chips, it may compete with the very companies that rely on its designs. Managing this balance will be important to maintain trust within its ecosystem. From a technical perspective, the chip is expected to focus on efficiency, which has always been ARM's strength. ARM-based processors are known for delivering strong performance while consuming less power compared to many traditional designs. This is why they dominate mobile devices and are increasingly being used in laptops and servers. The release of an in-house chip also reflects a broader trend in the industry. The line between chip designers and manufacturers is becoming less rigid. Companies are exploring vertical integration, where they control more parts of the process to improve performance and reduce dependency on others. In simple terms, ARM's first in-house chip is not just a product. It represents a shift in strategy. The company is moving from being only a technology provider to also being a direct example of how that technology should be used. What happens next will depend on how ARM balances its new role with its existing partnerships. For now, the key takeaway is straightforward. ARM is not just designing the future of chips anymore. It is starting to build it as well. Firms such as Meta and Google are reportedly involved in early adoption and collaboration. This suggests that the product is not just experimental, but already aligned with real-world data center needs.